So in this example, we're going to take the same solid area between y equal root x and y equal x that we had in example 3, except we're going to rotate around the line y equal 1. And in fact, why don't you pause the video for a second here and attempt to draw that solid and set up the integral that gives that volume. Okay, so let's go ahead and draw that line in here. Y equal 1 is horizontal line up here. Let's see, I'm going to go ahead and do that in black. And that is the line y equal 1. And let's go ahead and sketch the reflection of this solid. So let's go ahead and extend our y-axis. And then this line, the reflection will be there. And then the reflection of the square root curve is going to look like this. Okay, and we are spinning that around the line y equal 1 like that. So this is going to form a kind of sideways funnel. It'll look like this. And then we want to, we're going to be adding up washers here in the x direction, so parallel to the x-axis. So this is going to be an x integral. So pick a general value of x, and then draw the washer that's at that position. So that is going to look like this. It's going to have an inner radius right there and an outer radius like this. And then have a thickness to that washer, which is going to be delta x. So that washer is going to look like that. So we're going to add those up in the x direction from x equals 0 out here to x equal 1. So again, our volume is going to be the integral from a to b of pi times our radius squared. And in this case, we're adding things up in the x direction, so dx. And then if you've got inner and outer radius, it's outer squared minus inner squared. So for us, we're going to be integrating or adding up those disks from 0 to 1, pi, and then we want an outer radius squared and an inner radius squared. So we're going to go from the line y equal 1 down here to the equations that we know. This one is y equal x, and then this one is y equal root x. So our inner radius right here, so that's going to be our inner, and the top, which represents the center, is at y equal 1 at that point. And then the y coordinate of that point right there is square root of x. That's on root x. So this is going to be 1 minus root x. And then our outer radius here, so the upper end of that radius is at y equal 1, and the lower end is at y equal x. So our outer radius is 1 minus x. So outer radius, 1 minus x, that gets squared, minus the inner radius, 1 minus root x, and that gets squared. Close it up, and dx. So there's our setup. And then performing this integral is not too bad here. You're going to FOIL this out, collect your like terms, and then it'll be power rule. Okay, so we know how to finish that. So that's going to be expand and then plus power rule. Okay, so try those last two WebWork questions 4 and 5.